So this is a big deal, though it might seem natural to you, which means that we can say the following thing. It's a linear operator, so it should have a spectrum. So there should be a set of eigenfunctions. A is integrated on the orbit. So that's why we actually introduced it. This was reverse engineering, so I can get a multiplicative operator, so I can use all the machinery we have for linear operators and matrices. So there should be a set of eigenvalues, and alpha equals 0, 1, 2, There should be a set of eigenvalues, and there should be a set of that satisfy the eigenvalue equation. And if this was quantum mechanics, you're familiar with it, you'll find energies here as dual to time. So you know that if you have a compact thing like harmonic oscillator, you have discrete spectrum. So you've seen it, but quantum mechanics is much nicer because these operators in quantum mechanics are self-adjoint, but they're not self-adjoint in general, and certainly not in dynamical systems. So this is all non-obvious. It's not obvious that there will be discrete spectrum. When you have things that have to do with functions, you can also get continuous spectrum. So when you have a scattering problem, there could be continuous thing. So this is very sketchy. But this is the motivation why we are setting up this whole machinery. Jacobian was simple because that acted on a finite dimensional state space. So we have the Lorentz attractor Jacobian was 3 by 3 matrix. This is much harder because we're looking at a function defined over 3-dimensional space. So this is an infinite dimensional matrix if I think of it in terms of matrices. If I expand the function in terms of Fourier coefficients, there is infinitely many. So this operator is just like in quantum mechanics, it's acting on functions rather than points. So Jacobian was very simple, but the structure is the same. It's just that when we work with finite matrices, we're unlikely to do things very wrong. When you work on infinite spaces, then you really have to worry about what kind of function space, what kind of spectrum you can get, etc. So that gets much harder.